Hello everyone, welcome to our daily physics problem. Day number 43. So today we have two wheels that are attached by a belt, each with mass m1 and m2, and radius r1 and r2, respectively. The wheel 1 is rotated by a torque clockwise, and wheel 2 is exerted by a torque counterclockwise. There is no relative motion between the wheel and the belt. What is the angular acceleration of wheel 1 and wheel 2? So I want you to pause the video, try your own. If you try, come back to the video, then we will solve it together. So welcome back, guys. So first, we need to write out our force component along the belt, the tension of the belt, T1 and T2. Then we can equivalent the torque with the moment inertia of the belt times the angular acceleration. So the first one, let's assume that T1 is bigger than T2. Let's just assume both works other way. So we have T1 minus T2 times R1 plus a torque, it's in the clockwise direction, F equal to the moment inertia of the first wheel times the radius of the first wheel. Right? We can equivalent the torque and the angular acceleration and moment inertia. Then same for the second one. The second one, torque is counter to the force exerting in the direction. So we have T1 minus T2 times R2 minus the torque prime will be equal to I2 times R2. Oops, this is not R2. This should be alpha 2 and alpha 1, not R2. I'm sorry for that. So also, because we know they're connected and there is no relative motion, we also know that the linear velocity alpha 1 times r1 is equal to alpha 2 times r2. The linear velocity has to be the same. So by we having these three system equations, we can solve for the angular acceleration of alpha 1 and alpha 2. So how we do that? Let's first cancel T1 minus T2. Let's pretend this as a whole term called the changing T, let's say. So we know that I1 alpha 1 minus torque divided by R1 equal to this one is equal to I2 times alpha 2 plus torque prime divided by R2, and that is equal to this one, and these two are equivalent. Then we can try to solve for alpha 1 in terms of alpha 2. So what is alpha 1 in terms of alpha 2? Alpha 1 times I1 times R2 minus torque times R2 is equal to R2 omega 2 times R1 plus alpha prime, the torque prime times R1. This is R1. Okay. Then we can keep going. Alpha 1 will be equal to I2 alpha 2 times R1 plus alpha prime R1 plus torque times R2 divided by I1 and R2. So now we solve for alpha 1. Let's plug into this function to solve for alpha 2. So alpha 1 is equal to I2 times alpha 2 times R1 plus torque prime plus R1 plus torque plus R2 divided by I1 times R2 times and then times R1 is equal to alpha 2 times R2. So now you can divide both sides by R1 and multiply both sides by I1 R2. We have R2 divided by I1 R1 is equal to this expression. Okay, so now let's keep solving. So we can exert out some terms. Here we just minus both sides by this term here. Okay. Now we can solve for alpha 2. Let's just cancel out the negative sign. So negative sign we can cancel to switch this term. We have this one divided by this minus this. Oops. Okay. Then we can multiply both sides of the denominator and numerator by R1. Can simplify the equation furthermore. R1 times square plus divide by I1 minus R2 1 square. Okay, now we need to remember that the moment inertia of a disk is equal to 1/2 mr square. So this R1, well, let's just keep R1 outside, it's better, plus 2 divided by R2 square times 1/2 m1 R1 square plus R2 square times 1/2 m2 R2 square. Okay, now we can multiply both sides by 2. Both sides by 2. Oops. Here we'll do 2. Then we can cancel out R1. 2 times R1 prime divided by M1 times R1 divided by this. These two cancelled. M1 is not here. M1 minus M2. This one should be a minus sign because here is a minus sign. I forgot about that. So that's the solution for alpha 2. Then we can just plug in alpha 2 into this equation to solve for alpha 1. So alpha 2 is here. Then we can multiply both sides by we can multiply alpha 2 by 1 over R1 and then multiply by R2, we can get the alpha 1. So alpha 1 just simply equal to 2 times alpha 2. We can cancel out this alpha 2 and then divide by alpha 1. Alpha 1, we can square this. So alpha 1 square alpha 2 m1 minus m2 here times R1 plus R2 times this, and that's our final solution. Thank you for today.